In this video, we are going to find the circumcenter of a triangle, and then by extension, we're going to create a circumscribed circle around this triangle. Okay, so circumscribed circle means it's going to go on the outside of the triangle is going to go on the inside, which is also called a circumcircle, which seems overly complicated, so I usually just say circumscribed circle. Try saying that one 5 times fast. Okay, so a circumcenter, let's start there. This is found by connecting 3 perpendicular bisectors of the sides of our triangle. As it turns out, this is the official definition. You actually only need to construct 2 perpendicular bisectors, because once those 2 intersect, you have your point of intersection, right? It's not like when you draw the third one, they're miraculously going to intersect at another place. So you actually need to draw 2 here, but the true definition is that it's 3 perpendicular bisectors. So let's go ahead and start that. I chose an obtuse triangle to demonstrate this, because if you watched the intro video, you know then that a circumcenter can be on the outside of a triangle when it's an obtuse triangle. If you click on the link in our first set of notes to Math Open Reference, they show you an acute triangle, the circumcenter of an acute triangle. So if you'd like to see that one, it's there. So I thought I'd mix it up and show you an obtuse one here. So this we know is going to fall on the outside of the triangle, so be prepared for that. Don't think that something's going wrong. Pick any 2 sides you want to do the perpendicular bisector of. I think I'm going to do these 2 here and leave the big one. So let's get started on that. Come to this side, more than halfway, that looks good, and I'll go 1, 2. Keep that setting, come to the other vertex, and I will perpendicularly bisect this by finding the 2 intersections. There we go, there's 1. And we'll go ahead and sketch that. Now, since I know this is going to fall outside the triangle, I'm going to make this line really big, because, you know, we want to make sure that these 2 lines cross. If you don't do it long enough, you might not see where they cross. So I'm just going to be overly cautious here and make this line humongous. Like that. Okay? So of course this is perpendicular and this is bisected down here. Swing around. Let's do it to this side here. Okay. Let's make this a little bit bigger, since this side is a little bit bigger. And it starts to get a little bit messy here. Just try to keep track of your lines. So this looks very close to the line I just made, but we're looking at the outside one here. And I'll go again. Oops. Got to do the other side. So I did the top one, and I'll do the bottom one. And now I'll come to this side and do the intersection like that. Again, just keep track of your lines. The smaller one on the bottom here was from that perpendicular bisector. I want the one on top for the new one I'm doing, so just pay attention to those intersections there. And yours might look a little bit different depending on the setting you picked when you drew this, so I could be explaining this and yours doesn't even look like that. So connect those. This is perpendicular, this is bisected, and I don't need to do the third one, because as you can see, here's 1 line, here's 2 line. They intersect at this point. It doesn't really matter if I draw the 3rd line or not, because, I mean, we can to confirm it's going to go also through this point, but if it doesn't, it means that we did something wrong, right? Because it's not like these lines are going to miraculously intersect at another point where the 3rd line converges. So this is our circumcenter right here at this intersection. So that takes care of the first part of this, to construct a circumcenter. And now we want to do the circumscribed circle. So what that basically means is this is the center of a circle that will encompass the entire triangle here. Now, the really cool thing about circumcenters is that you can pick any one of these vertices. So you can pick this one, this one, this one. I'm just going to go for this one right here. Okay, so let's focus on this. The cool thing about a circumcenter is that it is equidistant from all 3 of the vertices. So see how I've measured this out? This is the length of my radius. If I were to measure that to this vertex right here, boom, it's the same length. Let's do it one more time and measure it to this one right here. Boom, it's the same length. So the cool thing is that we only need to measure the radius to one of the vertices, and then we can just draw a circle and it's going to hit all the other vertices. So check it out. I have my measurement. I'm going to go all the way around like this. Oop, I got to avoid the tripod here. All the way around. And you see that it perfectly lines up. You see that? I did not move at all. I just drew a perfect circle around the circumcenter, and boom, it hit this vertice, it hit this vertice, it hit this vertice. So in essence, the circumcenter is equidistant from every point on the triangle, every vertex on the triangle. There you go.